Alright, so we've been really getting into fractions now, and now we're going to start comparing fractions. What I mean by that is just like we compare numbers to see which number is bigger, which number is smaller, we do the same thing with fractions. You know, if you go to a birthday party and you're offered a piece of cake, and they say, do you want 1/4 or 1/3, and you want the bigger piece, you're going to want to know how to compare them in order to pick the bigger piece, right? So the obvious way to compare fractions is by drawing pictures and breaking them up into the same shape, and then breaking them up into the fractions. Like if you see in the middle of the screen, we have 3/5 and 1/5. I could draw a circle, two circles that are the same size, break both of them up into 5 equal parts, shade in 3 parts of one and 1 in the other, and I can compare them visually and see how much bigger one is than the other. But what we're going to show you today is how to do it by just using the numbers in the fractions. And specifically, we're going to talk about if the denominators are the same, or if the numerators are the same, but the denominators are different. So the first, and here's this saying right here on the front of the screen that you're going to hear repeated quite a bit in class over the next few days, okay? The first part is right up here, right here. If the denominators are the same, remember denominators, the bottom numbers, are the same, the greater the numerator, the greater the top number, the greater the fraction. Okay? So as you can see here, I have 3/5 and 1/5. The denominators are both 5, so I look at the numerator. In one it's 3, and the other is it's 1. 3 is bigger than 1. So therefore 3/5 is greater than 1/5. And this first one is the easy one to figure out, and I'll show you why when we look at some pictures, okay? It's this bottom one that's a little bit difficult because it just seems funny and doesn't seem right, okay? And that's this one down here. If the numerators are the same, the greater the denominator. So if the numerators, the top numbers, are the same, then the greater the denominator, the smaller the fraction. You're like, wait a minute, Mr. G. You're telling me that if the number is bigger, it means that it's actually a smaller number? And in fractions, that's exactly the case, and we'll show you exactly why in a little bit. So when comparing fractions, if the denominators are the same, the greater the numerator, the greater the fraction. If the numerators are the same, the greater the denominator, the smaller the fraction. Alright? And here's why. See this pie here is divided into 4 pieces. If you want to eat the most of that pie, you're going to want to know what's bigger, right? 1/4 or 2/4. If you're hungry and I offer you, hey, you can pick either 1/4 of the pie and 2/4, you're going to want to know how to compare fractions so you can pick the biggest part. Or maybe you're on a diet like Mr. G is, and you want to pick the smaller part. Okay? That's why it's important to be able to compare fractions. Plus, there's all other reasons why we need to as well. So look in here, okay? This again illustrates if the denominator is the same, then the bigger the numerator, the bigger the fraction. If you look up here, we're comparing 2 fractions here. The top one here is 1/4, okay? The bottom 3 here is made up of 1/4 plus 1/4 plus 1/4, or 3/4. And this is why I said this one's pretty easy. They both represent fourths. Okay? This is just 1/4, and this is 3/4. So it's obvious that if you were really hungry, that you would want to choose the bigger one, which is 3 out of 4 pieces, not 1 out of 4 pieces. So when the denominators are the same, that top number tells you how many pieces. Obviously, if the top number is bigger, then you have more pieces of that pie or candy bar or whatever it might be. Okay? Let's look at another example. Well, that was our last example for that one. Okay, we'll look at a couple more after we go over the next step. So again, going back to that example, the denominators are the same, then the greater the numerator, it means you have more pieces, so you have the greater fraction. Now we're going to take a look at if the numerator is the same, the greater the denominator, the smaller the fraction, and why this is true. Alright, here we have 1 whole pie. Now it's important to realize that when we're comparing fractions, we're comparing the same whole. We're not comparing a large pie to a small pie, a large pizza to a medium pizza, and so on. When you compare fractions, the whole has to be the same. You can't compare fractions of a king-size candy bar to a smaller candy bar. That's not quite how it works. You know, half of a small candy bar might be smaller than 1/4 of a giant king-size candy bar. So when we're talking about comparing fractions, we're talking about the whole, this whole pie right here, being the same. So here we have this whole pie cut up into different fractional pieces. What you notice if you go around and you start here, okay, here is 1/6 cut into 6 pieces. Then there's 1/8, the pie is cut into 8ths, and then you get 1/10. What do you notice about the pieces as you move from each different pie, from this pie to this pie to this pie? Pause it and tell a parent or a brother or somebody near you. If no one's near you, just say it out loud. What do you notice different about these pieces? Especially compare these two here. That might help you even more. What you'll notice is that as you start to divide this pie into more pieces, the pieces get smaller. So yes, 10 is more than 6, but what 10 is telling you is that I have 10 pieces, not 6 pieces. And so my pieces, in order to have 10 pieces of the same pie, they need to be smaller pieces than if I have 6 pieces. This is why when your numerators are the same and your denominators are different, the bigger the denominator, the smaller the fraction is. Just look at these 3 pieces right here. 1, 2, 3. That would be 3/10, right? And it covers up this part of the pie. Now look at 1, 2, 3 pieces out of 6. 3/6. That is 3 pieces as well. So we're comparing these because the numerator is the same. Both numerators are talking about 3 pieces. But because we broke 1 into 6 pieces and 1 into 10, this is a much bigger fraction. In fact, you could probably figure out that is what other fraction? 1/2 of the pie. And we'll get into equivalent fractions in a little bit. Okay? But 3/6 of that pie is actually 1/2. Those pieces are bigger. So as the denominator, as the number gets bigger, the pieces get smaller, making the fraction smaller. Okay? So let's look at a couple examples right here. We have 5/12 and 9/12. The denominators are the same. They're both 12. So we look to the numerator, the 5 and the 9. If the denominators are the same, the bigger the numerator, the bigger the fraction. So 9/12 is going to be greater than 5/12. Or another way of saying this is 5/12 is less than, here's our less than symbol, 9/12. Now we look down at 7/9 and 7/10. Now the denominators are different. One's 9 and one's 10. But the numerators are the same. We don't need to draw pictures. We just have to go back to our saying. If the numerators are the same and the denominators are different, the bigger the denominator, the smaller the fraction. These 10 pieces here are going to be smaller pieces than if I cut that cake or pie or whatever into 9 pieces. So therefore 7/9 is going to be greater than 7/10. Now we can also use fraction strips to compare fractions when we don't have or you guys have used fraction strips before on your desk at the beginning of this. Those fraction strips, we can pull them out and start comparing. We have 1/2 and we have 3/6, and we want to say, okay, well, which one's bigger, half of the pie or 3/6 of the pie? This is a little bit different because in this case, the denominators are different and the numerators are different. We can't rely on our on those two sayings in this case. So in this case, we need to draw pictures, which I'll show you in a minute, or use fraction strips. And if I compare the fraction strips and line them up, I'm actually going to see that these 3/6 are going to be the same. Look at that, 3/6. This is what we call an equivalent fraction. And again, we're going to get more into that in another lesson, okay? But we can use the fraction strips to compare when our two sayings don't match up, if the denominators and numerators are both different. Or we can draw pictures, like I did here. I'm comparing 2/3 to 3/4. So I drew a circle, two circles that are the same size. Remember, they have to be the same size in order to compare. And then what I do is I color in 2/3, and then I also color in 3/4. And I can look at them and compare them, and which one, and I'm simply just asking myself, well, which one looks bigger? And this one might be a little tricky, but the real easy way for this one is I look at what's left. This piece that is left is bigger than the piece that is left here. So that means this 3/4 took more of the pie away. So more of the pie was eaten in this one. So therefore 3/4 is going to be greater than 2/3. Or, if I'm reading this correctly with my symbols, 2/3 is less than 3/4. And again, I just want to show you another picture of fraction strips. I'll take that same example here. We have 3/4, so I need 3 of these. And then I compare them to 2/3. And whichever one's longer is obviously the bigger piece. Now again, these are pretty close, but you can still see that I have 3/4 are longer with my fraction strips, are closer to, if I even want to bring this up and match it up to 1/2, okay, then I could see that 3/4 is going to be closer to 1/2 than 2/3. So therefore 3/4 is bigger. Those are really the ways of comparing. The other way we will talk about comparing is using benchmark fractions and also comparing fractions on the number line, but that will be in a little bit later lesson down the line. Okay?